In this tutorial, we're going to show how to connect VTScada to a Modbus TCP IP device. We're going to set up tags in VTScada to read the Modbus registers on the device, and we'll finish with displaying live tag values on the VTScada HMI. To complete this tutorial, we're going to use SimServe by Scadamatic to simulate the Modbus device. SimServe has been installed on a separate computer that's connected to the same network as VTScada to make the example as realistic as possible. Now, we'll launch the web interface to SimServe. For our tutorial, we just need a single Modbus TCP IP device, so let's create it now. Let's name it Device 01. For the protocol, we'll select Modbus TCP. For simplicity, we want to assign Device 01 to have all IP addresses of the computer it's installed on, which is accomplished by entering 0.0.0.0 into the IP address field. This means the device can be reached by the computer IP. We'll leave the Modbus port at default 502. Sometimes, the interfacing applications interpret the bit, byte, or word order of numbers differently. To account for that, SimServe allows the desired order to be specified. To make SimServe work with VTScada, set the orders as shown. If these orders are not adjusted, the numbers in VTScada may not match the numbers displayed in SimServe. Now we'll click Save and observe that the device was created. Let's open the device now to see the registers. Now that we've simulated the Modbus TCP IP device, let's jump over to VTScada and set up the connection to this device. In preparation for the tutorial, an application has already been created that has a page with graphics on it. The tutorial will just show how to create the Modbus connection and tags, and we'll assume the viewer is already familiar with the basics of setting up a VTScada application. Let's open the pre-made application called Modbus Demo. We'll start off by creating a connection to the Modbus device on SimServe, which is done in the Tag Browser window. Launch the Tag Browser window. To keep things organized, we'll quickly create a context called SimServe to hold all items related to the connection of the Modbus device. We'll assume you're somewhat familiar with this process, but if not, there's a lot of good information available in the VTScada help to teach you about how to create a context. Now, we'll set up the communication chain to the Modbus device. But first, let's discuss what a communication chain is before we dive into the configuration. In VTScada, a communications chain consists of 3 links. The first link is a port. The port tells VTScada how the physical device is connected. The second link is a driver. The driver tells VTScada which communication protocol to use and allows the user to specify protocol-specific settings to communicate with the device. The last link is the memory addresses of the data in the device that should be read into VTScada tags, and these addresses are specified in VTScada I/O and calculation tags. Information flows from the device through the port to the driver, and data gets stored in the appropriate I/O and calculation tags. Let's start by creating the port. Within the SimServe context, create a new TCP IP port. Name it port and give it a useful description. On the Connection tab, specify the TCP IP port details of the Modbus device we're connecting to. In our case, the Modbus device IP address is 172.31.45.135, and the port is 502. Leave everything else as default. Now, let's move on to the driver. Within the SimServe context, create a new Modbus compatible device driver. Name it Channel and give it a useful description. On the Options tab, select the type of Modbus protocol being used. In our case, it's Open Modbus TCP. On the Communications tab, link the driver to the port we just created. Leave everything else as default and click OK. We've now built the first 2 links to the communication chain. Next, we need to create I/O and calculation tags that link to the Modbus registers in the device. We'll start out by creating a tag that's linked to coil register 1 in the Modbus device. Within the SimServe context, create a new digital I/O and calculation tag. Notice we're using a digital tag because a coil register is a single binary bit. We'll name the tag tag1. Then we'll go to the I/O tab. We'll link the tag to the Modbus driver. We need to use special syntax that tells VTScada how to look in device 01 and read a coil register at address 1. We write the register type, which is HC for holding coil, followed by the register address, which is 1, followed by slash, followed by the data type of the register value, which is bit. Later on, we'll be showing the creation of several other tags which refer to different Modbus register types and data types to teach the syntax. Now that the tag has been created, take a look at the value column and you'll see it says off. If we go over to SimServe and change the register value, you'll see the value column updates to match the register value. Lastly, notice the question mark to the right of the value column. The question mark means the tag has been flagged as questionable. By default, newly created tags are flagged as questionable to notify the programmer that the tag needs to be tested. Because we just tested the tag, we'll turn the questionable status off. Now, we'll quickly link this tag to an existing graphic. We'll go back to runtime. If we view the value in the HMI, we'll notice it's currently 0. If we go to SimServe and toggle the value, we then see a matching value in the HMI. Now, we'll repeat this process for tags pointing to different registers and data types. In the tag browser, we'll create a second tag called tag2. We'll keep the settings the same as before, but this time we'll read discrete input register 1 and set the read address as shown. IC for input coil, followed by 1 for address 1, followed by slash, followed by bit. We'll link the tag to graphics now and view it in the HMI again. Now, we'll go to SimServe, navigate to discrete input 1, toggle the bit, and see it update in the HMI. Moving on to tag 3, which we pointed to analog input register 1 as an unsigned 16-bit integer. Take note that we're setting the I/O and calculation tag data type to discrete instead of digital. See that the read address is now IR for input register, followed by 1 for address 1, followed by slash uword for register value type unsigned word. Let's link the tag to graphics and view it in the HMI. Let's go back to SimServe, navigate to analog input register 1, and enter a unique value. Then we'll check the HMI to make sure it was properly updated. Moving on to tag 4, which we pointed to analog input register 2 as an unsigned 32-bit integer. The data type for the tag will be discrete, and the read address will be IR for input register, followed by 2 for address 2, followed by slash dword for register value type double word. Now we're linking the tag to graphics and we'll view the current value in the HMI. Let's navigate to SimServe and change the value of the associated register like we did before. However, this time, rather than changing the register value directly, we'll create a tag in SimServe that points to the register and change the value via the tag. We're going to do it this way because a 32-bit unsigned integer spans 2 Modbus registers, and it requires some math to determine the appropriate value for each register to display a desired value in the HMI. Creating a tag in SimServe instead lets SimServe handle the math for you. Go to the Tags tab. Click Add Tag, then enter the name of tag 4, set the data type to uint32, the starting address to 3x2, and leave the initial value as 0. Enter a unique number for tag 4. Before we check the HMI, take a quick look at the Register tab again. you'll notice that 78978 was entered for the tag value. However, register 2 is 13442 and register 3 is 1. This is the conversion process that SimServ is handling for us. Now, if we check the HMI, we see a value of 78978. Now we'll make tag 5, which will be pointed to analog input register 4 as a 32-bit float. The tag data type is set to analog, and the read address is IR for input register, followed by 4 for address 4, followed by /float for register value type float. We'll link the tag to graphics and view the current value in the HMI. We'll then navigate to SimServ, create tag 5 in SimServ, and assign a unique value. We see the HMI shows the correct value. Let's create tag 6, which will be pointed to holding register 1 as a 16-bit signed integer. The tag data type is discrete, and the read address is HR for holding register, followed by 1 for address 1, followed by /sword for register value type signed word. As done before, we'll link the tag to graphics and view the current value in the HMI. Now we'll navigate to SimServ, create tag 6 in SimServ, and set a unique value. We see again that the value appears correctly in the HMI. Let's create tag 7, which will be pointed at holding register 2 as a signed 32-bit integer. The tag data type is discrete, and the read address is HR for holding register, followed by 2 for address 2, followed by /SD word for register value type signed double word. Again, we link the tag to graphics and view the current value in the HMI. Then we navigate to SimServ, create tag 7, and set a unique value. We view the HMI and confirm the correct tag value is displayed for tag 7. Last, we're going to make tag 8. We'll point tag 8 to holding register 4 as a 64-bit float. The tag data type is analog, and the read address is HR for holding register, followed by 4 for address 4, followed by /double for register value type FloatDouble. We link the tag to graphics and view the current value in the HMI again. We then navigate to SimServ, create tag 8, and set a unique value. We verify the value appears correctly in the HMI. So that's the process. That's how tags in VTScada can be linked to Modbus registers in an external device. I know there's a lot of steps, but hopefully this video eliminates some headaches for you in your future integration work. Lastly, as the tutorial shows, SimServ is a great tool to help work through VTScada to Modbus integration challenges, and I recommend checking it out. Thank you for watching, and please reach out to us at support@scadamatic.com if you have any questions we can assist with.